Okay, student, today we go to the lesson 4.3, part 2. That's talking about the application for the transistor. Okay, let's see the topic. Okay, now we go to the first one for the application. There's an amplifier. So this one they show about the transistor circuit. So from here we're using the microphone, then we're using the earphone. Okay, let's see the transistor how to function. Okay, first one, when the person they start to speak through the microphone, the sound wave they will convert to the alternating current. Okay, when they just control become the alternating current, the small changes of the base circuit they cause about the base current to flow. When the convert become alternating current means the base current they start to flow to the base circuit. Okay, after that they will go through to the transistor. So they say a small change of the IB. Maybe you talk soft, later you talk about louder. So your big changes for the IB, they will cause about the big changes for the collector current. So the earphone, they thus they receive to the large alternating current from the collector circuit, then they convert become louder sound. So from here we put the capacitor at the starting point because they can block about the steady current. The steady current here is a direct current. So from flowing through the transistor and also the microphone. So that means all the current they flow through the transistor and also microphone, they must be the alternating current. Okay? Okay, now we're going to see the diagram. By using the diagram, we go to memorize how to explain. Okay, we don't need memorize word by word. We just see the number. Okay, let's start with the number 1. Number 1, they show with microphone. So from here must be audio sound. You're talking, okay, through the sound. After that, they convert become alternating current. So this one is a sound signal convert become electrical energy. Okay, after that, we got capacitor. Capacitor block at the middle. So you must say about the capacitor what's the function. They just allow the alternating current flow in. Okay, after that they flow in, then must go number 3. Number 3, now they got base current. Base current will pass through the transistor. Okay, then we go number 4. Number 4 must be the collector current. So you just say about the small changes of the base current, they produce the bigger changes of the collector current flow through the collector circuit. So finally must go number 5. The sound wave with the higher amplitude is produced through the loudspeaker. So this one is a function for the sound amplifier by using the transistor. Okay, now we go to the another function for the transistor. They're just like the control switch. So this one they control about the light. So we're using the LDR. So the LDR stands for light dependent resistor. So from here, LDR you can put at the bottom. You also can put at the top. We got different function. So first one, we need to know LDR, what is the characteristic. So first one, characteristic you need to know is during the bright light, that means during the day. Okay, LDR has low resistance. So this one is a characteristic, LDR. So LDR is in low resistance when during the light day. Okay, when during the night, that means they don't have any bright only, they just become dark already. LDR, the resistance should be high. So that means LDR, they got controllable for the resistance. The resistance, not the fixed one. So when I put the LDR at the top, okay, this one is a voltage divider. Remember? So this one is a series. If there's a series, that means the current should be the same. The current for the both resistance become the same, but the voltage they will divide. Okay, now you see the first one, A. When bright light, that means during the day, LDR has low resistance. So V equal IR. If I say I already constant, because there's a series, so V potential difference and R resistance must be directly proportional. So now LDR, there's a low resistance, so understood potential difference also become low. Okay, if the LDR low potential difference means the rest voltage where they go to the bottom one, because there's a voltage divider. So if I say this one 6 volt, this one just 0.5 volt. So the rest one, 5.5 volt, where they go? They must go to this one resistor. Okay, so from here they say, therefore the potential difference across the LDR is low. Okay, and the rest potential difference, they will across to the resistor R, so they become high. Okay, high potential difference. If got high potential difference means they got current. So this one current, we call it base current. They will pass through the resistor, go into the transistor. Okay, when you got base current, so understood, you must have the collector current, and also the collector current must be multiplied. So finally, the bulb can be light up. Okay, so conclusion, I can say when the LDR put at the top, this one transistor circuit is light up the bulb during the day. Okay, during the day. If the question asks, if I want during the day, I don't want to light up the bulb, I want to off the bulb. Okay, what you need to do? So your answer must put the LDR to the bottom. When you put the LDR to the bottom, now the situation will be reversed. That means during the day they will off, during the night they will on. Okay, the situation just like this. If you during the day you on, means the situation is when the factory they start to work. Okay, they on the light. So that means during the day they will on the light, means the function still moving. The workers still start to work. So that means the whole factory is on. So they on the light. During the night, they do not on the light, means off the light, means now the factory is closed already. Okay, if I put the LDR at the bottom, that's another function. So example, this one is for the sideboard. Example for the company sideboard. During the day, the sideboard is off. Okay, the light is off. But during the night, okay, they want to on the sideboard. So just like the lamp for the traffic, for the light. Okay, the lamp of the side, roadside. Okay, during the night, they will on the light. Then during the day, they will off. So this one is a situation we call light control switch. Okay, now we see during the night what happened for this one situation. Okay, during the night, LDR, resistance automatically become increased. So now high resistance. So therefore, they get high potential difference. How about the resistor? This one resistor, the potential difference become very, very low. So if resistance here fixed, potential difference become very low, that means they don't have any base current. So from here, the base current does not flow through the base circuit. So if they cannot go through the base circuit, means the transistor cannot function. Transistor cannot function means don't have collector current. No collector current, finally the bulb does not light up. So from here, if the position of the LDR and also the R interchange, if I terbalik interchange the position, so you find it the situation is the bulb will switch on during the night and also off during the day. Okay, so you just see the situation what you want, depend the function. So that means we can switch up and also the switch down for the LDR. Okay, now this one is during the night. During the night, we see what happened for the light control switch. Okay, we're using the diagram to memorize. Okay, label by one. Okay, first one they label by the LDR. This one's a symbol for LDR. They say the resistance during the night is high. So from here, LDR rises considerable. Okay, after that, you are talking about the potential difference. Potential difference across the X, Y, they become very large. Okay, how about number 3? Number 3 is a YZ. Potential difference decreases. When it decreases, how about the base current? Current IB become very, very small. Okay, too low already. Cannot switch on the transistor. If they cannot switch on the transistor, then we go number 5. Collector current becomes smaller. Collector current becomes smaller means the whole circuit cannot function. Finally, the bulb does not light up. Okay, so we're just using the 6 sentences to answer the process question. During the night, what happened for the LDR when they put at the top? Okay, now it's during the day. You see what happened for the LDR? Okay, now the light, they focus to the LDR. Okay, so from here you find it, the LDR resistance is decreases considerable. Okay, after that we say about potential difference across the XY. Okay, across the XY is decreases. across the YZ, the voltage now is increased. When it just increased, that means now you got current IB, base current increases, flow through the base circuit and on the transistor. After on the transistor, now the collector current can be flowed through. Finally, the bulb can be light up. Okay, so this one is a situation when the LDR put at the top, and during the day they will light up. Okay, another function for the transistor, there's a temperature control switch. If I say temperature control switch, I cannot using LDR because LDR just for the light. Now we need to using the thermistor. Thermistor want to detect about the temperature. Okay, before that, you also need to know what is a characteristic for resistance of the thermistor. Thermistor is during high temperature, they become low resistance. Okay, when the temperature become low, there's a large resistance. Okay, now I put the thermistor at the top. Okay, we see what happened. When the thermistor is cool, means the situation now is cool, temperature is normal. Okay, there has large resistance. Okay, when they have large resistance, means the potential difference is very high. Okay, so now potential difference across the R is low. Okay, if potential become low, we got any base current or not? The base current is decreases. When the base current decrease, that means transistor cannot on, collector cannot on. So finally, the bulb does not light up. So from here, we conclude the situation. This one normally we using for the alarm, the silent. So that means during the temperature is low, that means normal temperature. So the bulb do not light up. The silent do not on. So this one is correct. This situation is okay. Okay, now if during the night what happened? Sorry, not during the night. It's during high temperature. If high temperature, thermistor resistance become low. Potential difference across thermistor also low. But potential difference across the resistor R become high. So base current go through transistor. After that, the collector circuit is on, the bulb and also the silent is on. So this situation is when the temperature too high, that means the fire drill. Okay, high temperature, so finally the silent can be on. So this one is when the thermistor put at the top, suppose there's a normal connection if you're using for fire drill. Okay, this one is another one. There's a heat control switch. Okay, same like just now. Just now is a temperature, now it's a heat. Okay, also using thermistor, we're using the number through the diagram to memorize the process. Okay, first part is the temperature high for the thermistor. Okay, then the resistance will become low. Okay, temperature high, resistance become low. Okay, resistance become low means potential difference here become low. Okay, potential difference across the R become high. So now base current flow through the transistor on. When the transistor on, okay, now in number 4, they put one of the relay switch. Relay switch, the function is want to increase the voltage. Maybe the alarm, the voltage is a high. Okay, the supplier here, the potential difference is very small. You cannot trigger the alarm. So they need the help for the relay switch, okay, to increase the output voltage. So from here, when you just trigger the relay switch activate, so the relay switch will continue straightforward, go to the alarm. Then they will on. Okay, so this one is during the temperature is high. Okay, so if you put the thermistor at the bottom, now the situation will be reverse. That means temperature high, they never trigger alarm. Temperature low, they will trigger the alarm. So depend the situation what you need it. So you need to put the thermistor, see which one location you want to put. Okay, so our lesson just until here only about the application for the transistor, they apply for the amplifier, apply for the LDR, and also for the temperature control switch and also heat control switch. So the following you need to do is tutorial 4.3. Okay, finish your 4.3, that means that coming soon I will show you the answer and also discuss the question. Okay, so from here, thank you for your watching. See you soon.